Welcome to this ESRA short movie on AI in surveys, in particular the training of machine learning models. Is there a resemblance of training these models to surveys, and in what way? Can surveys help? And vice versa, what's the role of machine learning models in surveys? Let us hear what experts Christoph, Kern, Stephanie Eckman, and PhD Bolei have to say about this. But before I do, I will show you two real applications. So I'm going to discuss two case studies where annotation is needed. They are very different case studies. One is a case study on the classification of products that people can buy anywhere in a store. It's a case study that we've been doing at Statistics Netherlands for a number of years. The other case study is on hate speech in tweets. And that's one that I will discuss with Christoph, Bolei, and Stephanie later on. So let's have a look. So what you're seeing here is one of the receipts that of myself. It's actually from a supermarket. It has a number of products. Most of the products are, of course, in Dutch, but you may recognize a few names like peanut butter. It's actually an English name on the receipt here. So my task is, if I have this receipt, to classify it according to COICOP. And COICOP is an international classification of products and services. It has 5 digits. It's very detailed. One of the digits is on food, one is on drink. And obviously in supermarket, I'm mostly in those two categories. So here's my receipt. For this, we have a very simple tool. It's a website that was created by my colleague Tom Oelemans. I can choose a language. So in this case, I will do that in Dutch, of course, so NL, Netherlands. But I could also do it in English if I have an English receipt. There are other languages, Finnish, for example, Hungarian, and so on and so on. The reason we have this international version is that it was a Eurostat project. And we cooperate with a number of countries in trying to create these machine learning models for products. Okay, so what you're seeing, I can look for a particular matching algorithm. This is based on string matching. So sort of how many edits do I have to do on my string to get to another one that I already have in my train data. There is another some setting that is about how the results are presented to me. And I can also set how many examples will be displayed, and so on and so on. Not very interesting for now. So let's go back to the receipt. My first is soya yogurt naturel. Let's see if I can classify this one. So this is how it's written. On the receipt, and indeed, there is a product name that looks like it, soya yogurt. The interesting part about this website is that it has train data that is already linked to a product category. And the product categories are actually the COICOP. So COICOP yogurt is actually on the lowest 5-digit level. Lay's Naturel is chips. It's a very different COICOP category, and so on and so on. So you see here the COICOP categories that have already been assigned by others. So now I can say, okay, this is the one that I have, soya yogurt. So this will be recorded. The text soya yogurt naturel is linked to soya yogurt, and then therefore also to the COICOP category. Let's look for another one. So here I have peanut butter. That would be a challenge because we're in a Dutch receipt, Dutch supermarket. Still, there is an English term. So it doesn't notice. There is something like peanuts, and there is maybe something like M&Ms, which is sweets, but it can't find the peanut butter because it doesn't know peanut butter as a Dutch term. So this one I will have to add later on by hand, as I already expected. Maybe a last one. Here is mango rapiers, which are slices of mango, just as an example. And indeed, it has mango. I can choose also for mango chutney, but that's definitely not what it is. It's mango. So here you can see how I can sort of go through these different texts, find the right product name, and then the product category by itself will be linked. The reason we do it like this is that basically any person will not be familiar with this kind of very detailed and bit abstract official language that is being used for the products in QuickUp. Okay, let's go to the other case study that we will discuss later in this recording. This is the one on hate speech. So I have to warn you in advance that it has offensive language. So in the hate speech case study, tweets are coded on two features, on two aspects, you could say. One is, does it contain offensive language? And second, would it be considered hate speech? Well, here you see the database, the website that has been created within the project. So there are quite a few cases, almost 90,000, really a lot. We may look at a few examples here. So you can see some of the characteristics of the coder, so who did the coding, but also here at the very end, the tweets. I'm not going to read them, but if you look at them, you will probably see they often have offensive language. So these are labeled. So you see here the different labels that are given to the different tweets. And this is actually the input to training that we will discuss later on. So I will also do a few myself, although I'm not English. I can give it a try. So here I have 7 tweets, and they are, like I said, well, are mostly containing offensive language. So you are a jigaboo is really an insultive offensive language. I would say retard is also offensive language. Scum, slant, offensive language. Racist Redskins. Not sure if we could see that as offensive language, but let's say that is true. Right bitch. I'm not sure if that's offensive language. Maybe not. Maybe I find it quite hard to say, but let's say that it's true. Dirty chink whore, yes, definitely offensive language. Great lead battle, then Ricky hits Danica for a yellow. I really don't know what that means. But to me, it doesn't look like it's offensive. Okay, then the next step would be to say, is it hate speech? Given that this is addressed at a person, I would not say it's hate speech because it's not about a particular group, it's insulting a particular person. Here I think it's actually hate speech. It's true. I don't know whether this is true. I would say no. No, it's just offensive language, but there is no hate speech here. This is not hate speech either, it's just offensive. And this one I really don't know. So let me say it's no. So if I have coded these 7 tweets on these 2 aspects, they can go into the database and they can be analyzed as part of the whole train data set. So this is actually how it was done, maybe not as simple as I'm now doing it. And I'm not an American or US citizen, so some of these words to me are a bit unclear. I don't really know what they mean. So I might not be the perfect coder here, but I guess you get the picture.
I have 2 experts here in the video. Stephanie Eckman, she is a data scientist and researcher at the Social Data Science Center of the University of Maryland. And Christoph Kern, he is a junior professor in social data science and statistical learning at Ludwig Maximilians Universität in Munich, in Germany. So welcome in the session. I noticed one thing that's pretty striking if you look at your evaluations, and that you both sort of refer to social data science, so it's maybe as opposed to social science. So what in your opinion is actually the difference between social data science and social science, or is there no difference?
Yeah, it's I think an kind of conceptual term that tries to bridge those two disciplines, I would say. Like data science as a discipline that kind of more kind of directly jumps in with kind of the data itself and then kind of goes ahead and sort of throws a lot of fancy models at it, and kind of social science, or specifically survey science, that is more maybe thoughtful and critical of how that data sort of came about and was constructed and collected. And to me, then social data science is well, maybe trying to combine those two perspectives and bring a thoughtful or critical perspective to data science, in a sense.
So you're talking about different disciplines. So what would those disciplines be?
Yeah, I mean, as I mentioned, I think data science on the one hand side, coming from like this intersection of computer science, machine learning, and kind of more technical research, and on the other hand, the social sciences as a broad tenet of, well, including survey methods, but also sociology, maybe psychometrics, those things.
So are these disciplines conflicting in a way or not? Are there social data scientists out there, or are there still teams with different disciplines?
I think we're forming social data scientists right now, in a sense. So it's still, I think, an emerging field. But it's also always a matter of definition. I mean, it's also sort of, in a sense, a made-up term. So I think everyone working in the space of survey research can kind of maybe allude to the term social data science in kind of translating what they do already to the CS or machine learning community, and maybe vice versa. On the other hand, might work in a similar way. So it's, yeah, I don't to me those are just kind of labels in a sense, and I mean we can use them flexibly.
Okay. Well, so Stephanie, well, we've been meeting each other at workshops for quite some years. Maybe 15 years ago, maybe you wouldn't call yourself a social data scientist. Maybe now you would. I don't know. Did you undergo a change in these years?
Yeah, I guess did I change, or did the field change and I adapted with it? Certainly I started my career as a survey methodologist and a survey statistician without the term data science. And this was like the early 2000s. I struggled actually for years to call myself a statistician because my degree was in economics. I've come to embrace the statistician term. And then as I was doing that, of course, the term data scientist was arising. There's a lot of debate about whether statisticians and data scientists are different animals. They use different terms and different techniques, but they're essentially, in my opinion, doing the same thing. So yeah, I would say that these days I am a data scientist. To build on what Christoph was saying, for me, I think the term social data science means two different things. One is the application of data science tools to answer social science questions. You know, why do people do what they do? What are people like in groups and individually? But also the application of like a social science lens to data science. So where does the data come from that you're using in data science? And who are the people behind that data generating process? And what do we know about them? And what does that tell us about the data quality, and ultimately what we can do with that data and what we learn on the other end?
Well, social science, of course, is a very broad field. You know, there's a lot of different areas in social science. Maybe social data science a little bit more focused already, but and I guess if we think about have ESRA in mind, then surveys, of course, have been very important in social science. So, is there any role for surveys in social data science, or is that an open door question?
I definitely think there's a large role for surveys in social data science. A lot of the big data sets that social data scientists use to study society come from large population level surveys or from other data sets, but then are benchmarked against these large population surveys. So even though the data you're using in any given day may not be survey data, I think ultimately there's survey data sort of in the background that we use to get a sense of like, is the data set representative? Well, in order to know that, we need to go to the population census or other large data sets like that. So in my opinion, there's a large role for surveys in the social data science world. And then I think what we're going to talk about today is another aspect of how surveys can affect social science, but I'll let Christoph contribute before I get into that.
Yeah, just adding maybe one additional field that I feel is currently also kind of sort of emerging is participatory approaches in the ML and AI space, where I can also clearly see like the value of like survey science on different levels. So who do we want to participate? So what is our target population? And just broadly for context, the idea is there to kind of get feedback from essentially the folks that will be affected by ML and AI models in the real world. And there clearly there's a need to include their views, their values, their perspectives, their risk perceptions, also kind of maybe alluding to critical measurement questions. So how do we measure those things, right? And again, kind of the representation question. So that's also a subfield at this intersection. I think that is super important.
Okay. Well, let us zoom in a little bit on the case studies that you've been doing. So you've been working with maybe what you could call annotators or external persons helping out labeling events or cases. These annotators are in a way like survey respondents, external persons, not necessarily very knowledgeable about what you're doing. So do you see a resemblance between annotators or persons helping out labeling cases and respondents in surveys? Is there an overlap?
Yeah, I definitely think that there is. This is really the foundational moment for all this whole stream of research that we're going to talk about today. When I saw the instruments that the annotators or the labelers were using to provide labels for photos or texts or product reviews or what have you, I thought to myself, that looks just like a web survey. Like physically on the screen, it looks a lot like a web survey. There's maybe a question or a statement with a few response options, and then you click next and you get to the next one. So I definitely agree that the annotators are a lot like respondents, or even in some cases interviewers, and this task is very much like a survey task. Of course, in surveys, you're often asked questions about yourself. What did you have for breakfast? Has a doctor ever told you that you have diabetes? Whereas when you're labeling or annotating, the thing you're seeing has nothing to do with you. You've never seen it before. You're never going to see it again, right? It's very external. So there are some important differences. But when I realized the similarities, I thought, I wonder if all of the things we know about surveys and what impacts data quality also carry over into the annotation task and would affect data quality there. And so that's the motivation behind a lot of the research that I've been doing with Christoph and others for years.
Okay, so you do see an annotator as a person that brings a context, that brings his, her background, and you think that's important. So whether you're older person, younger person, well, you name it, is that an influence in annotating that should not be neglected?
Yeah, it speaks to, I guess, also representation again. And for the task that we have been studying so far, I think it really makes a big difference. So imagine again, like subjective labeling tasks. I mean, speaking about classifying text snippets as being hateful or not, or containing offensive language or not. It really depends on your context, not just demographic, but also, I guess, like linguistic context, or like just like where you come from, which kind of country you're labeling from. Essentially, all of those things make a big difference. And then it's also a question when we have that complexity, when we think about the models and what the labels are eventually used for whom would they be applied? So it's an interesting way of thinking about population and target population. I think that the kind of the concept is super important and then kind of again valuable, and we kind of need to just adapt it a little bit, because here it's not necessarily super obvious what the target population is, but it should be kept in mind. And also I think it should be aligned with the training data sample, so to speak.
There may be a resemblance, in surveys we of course have the measurement representation, the two main arms of error. I guess you would have that in annotation as well. Maybe sometimes it's assumed that the representation is less so important as it is in surveys, or is that a wrong perception? Is representation of annotators equally important as it is in surveys?
I think you're right that both the measurement and representation error sources can come into play in the annotation task. And so we've done research more on the measurement error side so far, and we're starting some new projects now on the representation side. I agree with the intuition that it probably matters for, especially for some of these subjective tasks, who your annotators are, right? So for the example, Christoph mentioned annotating snippets of text as to whether they contain hateful terms or offensive language. Your personal background, the amount of time you spend online probably plays a big factor there, right? And so you'd want to get a representative sample sort of across a range of people and make sure that that matches the target population, with again the asterisks on the fact that we don't know exactly what the target population there is. I think that a lot of researchers in the machine learning field have underappreciated the role of both measurement error and representation error. You asked specifically about representation error. I think that is an underappreciated source of error in the annotation field. Some of the tasks that were popular annotation tasks like 5 or 10, even 10 years ago, were more like, is this picture of a cat or a dog? Is there an animal in this photo? Is this review positive or negative? And so they were often tasks that were less subjective. And in those kinds of cases, you can get away probably with a less representative sample. And so they would go out to a lot of these large crowd worker platforms and just, get anybody who would participate, essentially like a non-probability survey of people. You're paying per task, anybody can come in and do those tasks, and the representation wasn't so much a factor. Now that we're doing more subjective tasks, or even doing things like which of these responses from a model is fairer, right, or more appropriate, or the better answer, that's a very subjective judgment. And therefore, I think the representativity is going to matter even more going forward for these kinds of tasks that we're doing now.
And making maybe the bridge to surveys even a bit stronger. In surveys, you always, of course, have this sort of process of information retrieval, judgment, the famous steps in the cognitive process of answering a question. You can imagine this is also true for an annotator. This person is going through some sort of understanding, but there could also be fatigue, like satisficing in annotation, right? Is that so? For example, would you say, well, annotators at some point we should stop asking them because they are satisficing annotators right now?
I'm happy to take that one, but Christoph can address this as well. I do worry about fatigue effects in the annotation task. We've done some research suggesting that as annotators do more and more tasks, they become their annotations change and reduce in quality over time. And in particular, we've seen like a decrease in the probability that any given tweet is judged to be hateful or contain offensive language as the task goes on. It's a small effect, but there is a slight negative trend across the tweets that they do. That suggests to me that, yes, we probably want to limit annotators to a given number of tasks that we feel that they can do without showing too much of this fatigue effect. That is not standard practice in the annotation world. Generally, these tasks are it's a large pool of, say, images or text that needs to be labeled. And annotators can come in and do as many as they want, right? And they're paid per piece. So the more they do, the more money they make. And so I worry a lot that as the task goes on and we have more and more coming from one given person and the fatigue effect might set in, then that's going to cause problems for the models that are being trained down the line. Just like with interviewers, right? And this is the sense in which annotators are more like interviewers actually than respondents. We know that in surveys, you don't want to have one interviewer who dominates the data set and did most of the interviews, right? Because whatever small little interviewer effect that person had is now like a large part of the data set. And so again, if an annotator is sort of more or less likely to see a cat versus a dog, then and you have that annotator sort of dominating the data set, you're going to have that effect throughout the data set, and it becomes a bias then and not a variance. So the same kind of thing can happen that we see with interviewer effects. We can have the same thing with annotator effects.
Well, let's go to the other side of the story. You know, we have the annotators, but we also have the researchers. So the researcher is collecting the data, annotated data, and he or she knows there might be some issues here with the annotators. There could be some bias, there could be some learning curve, and all this. I think that was one of the goals of your experiment, to figure out what is the best strategy, what the best tactics. So what does this tell you in terms of if you are the data scientist trying to make sense out of this in the machine learning stage? Is there something, do you need to account for this sort of fatigue or for this bias? Do you remove cases because you think they're no longer important? What's the role of this in the machine learning part?
Yeah, maybe before jumping to kind of recommendations, I think one thing is to firstly be mindful of that your design of how you kind of set up the task does make a difference. And then just kind of also maybe even on the descriptive level, kind of understanding whether like certain kind of whether or not you use all of the data that you annotated or kind of just certain pieces of it, just kind of almost as a sensitivity analysis. That is something that you can do kind of regardless, right? Also in terms of how do you kind of deal with overlaps? So you might have, I think it's also typical that you have multiple annotations from different annotators for the same kind of document in a sense, and how do we use that information? And also, again, just kind of building different models using different sets and understanding where might be a good cutoff. I think that those are kind of descriptive things that you can do. With respect to the different specific experiments and the different conditions, I think maybe Stephanie can take this one.
Well, before we go to the results, let's first see what the experiment was about. This is the team behind the experiments, besides, of course, Christoph and Stephanie. Bolei, PhD, will explain the experimental setup.
Our research was allocated in the era of hate speech and offensive language. Given a tweet, and annotators were asked to give binary label for the two classes, hate speech and offensive language. And we want to test whether the order of the question wording will affect the annotations and models trained on these annotations. Let's take a quick look at the experimental condition. Just as clarification, arrow is duration of the annotation task, and each step on the arrow is a new screen. In condition A, the annotators were asked to simultaneously whether the given tweet is hate speech or not, and whether the given tweet is offensive language or not. Then, in condition B, the annotation for each tweet was split up. And given a tweet, on the first screen, we first ask for whether the given tweet is hate speech or not. Then, on the next screen, we asked whether the tweet is offensive language or not. And condition C just flipped the order. Well, in condition D, annotators first completed the hate speech annotations for all tweets followed by each. And after finishing the hate speech annotations, they were then asked to do the offensive language annotation for the same batch of the tweets. And again, condition E just flipped the order. And our data sourced from an open source hate speech dataset from Davidson. We selected 3,000 tweets from the dataset, and in total, we recruited around 900 annotators to label a total of 3,000 tweets, where each annotator did 50, and each tweet was annotated 15 times. That means we ended up with a total of 45,000 annotations. To train models, we split our 3,000 tweets in train and test, as shown on the right figure. Each of the tweets was annotated in each of the conditions, so we took training data from each of the conditions, trained a model on each of the training subset from condition A to E, and tested on test data from each of the 5 conditions, with validations across the conditions. We used the BERT-based model to train and evaluate on the data, and the metric we used for training and validation is AUC score.
So what were the conclusions from this experiment? Let's get back to Stephanie and hear what they concluded.
We studied the impact of the annotation version on the models in 2 different ways. The first was we looked at balanced accuracy, which is just a summary measure of how accurate the models are. And we saw that version A, which is the one where both the labels were collected on the same screen. There was a tweet and then the hate speech question and then the offensive language on the same screen. That version showed lower performance across the board for both hate speech and offensive language. And then the versions labeled D and E, which are the ones where the interviewer did all 50 tweets, answered the hate speech question, and then saw the same 50 tweets and answered the offensive language question, and then the converse, first offensive language and then hate speech. Those versions also underperformed on the question that was collected in the second half of the instrument. So if you did all 50 tweets with hate speech, and then you did all 50 tweets again with the offensive language label, the models trained on that data didn't perform as well in that balanced accuracy measure on the offensive language label, which was the one asked second. And this is what I was talking about earlier. This is evidence of a fatigue effect, as if the annotator went through the 50 tweets, did a good job on the hate speech question, but then when it got to the offensive language question and they're seeing those same tweets again, those labels seem to be of lower quality because the models show lower balanced accuracy when we're looking at the offensive language models. And then in the other condition where it was reversed and you first saw all 50 tweets and labeled offensive language, and then the same 50 tweets and labeled the hate speech label, the models underperformed on the hate speech label in that version. So again, that's evidence of a fatigue effect. So the balanced accuracy labels really picked out that first condition where both labels were collected on the same screen as underperforming, and then the second label collected in those other 2 conditions, D and E. The other metric we looked at to understand how the annotation versions affected the models was the predictions that are actually coming out of the model. So this gets to your question, Barry, about an unseen tweet. I'm trying to predict whether this is hate speech or offensive language. Am I going to see a difference there? And again, we saw that there are differences, in particular that model for the version A, where both labels were collected on the same screen. The predictions from that model were outliers and didn't correlate very well with the predictions from the other models.
Right, so this does point at something which you may call something like an annotation design. So it's not just go there and just do this, but you have to think very carefully how much you ask, in what order. Do you think that it's not an easy question, that this kind of design extrapolates to other studies? Do you sort of argue that if you would do something a little bit similar, or you would do a new study like this, the lessons learned should definitely be in that new study as well? So there's a design.
First of all, just a small point. We call this phenomenon annotation sensitivity, that the annotations you're getting are sensitive to the data collection instrument. The papers that we've written have so far been really concentrated on this tweet labeling task because it's relatively straightforward. It's subjective. We expect annotators to differ on how they do these kinds of tasks. It's easy to do in a web survey format. We haven't generalized it to other kinds of tasks. Would you see the same kind of thing with images or medical records? Potentially. That's something I worry about, but we don't have the research data on that yet.
Okay. Well, I've been showing another example that's from our own sort of setting that we were doing in household budget surveys, where we ask households to label their own expenses if we don't know. So we try to predict, okay, that particular product on your receipt is this and this, and then the household can say, no, it's not true. You guessed wrong. This is another product, and it's actually this one. But at the same time, we were a bit worried that, of course, they also have fatigue, or they drop out or whatever. So let's say in your case, is there something like drop out or break off, or annotators stopping because they don't like the task anymore, or
maybe I could also just add something to what Stephanie just said on our kind of current kind of work in the labeling space. I think one kind of higher level piece also that we've found when it comes to kind of generalization and think about other tasks is that it's not always obvious for which measure or kind of outcome metric actually kind of those changes that we make a difference. So we saw kind of differences in model performance for the paper that we just talked about, but we saw differences in another specific performance measure for a different change when it comes to more on the representation side, where we looked at, okay, what happens if we are kind of looking at the composition of the annotators and how that aligns with the target population, kind of in a simulation setup. And there we kind of saw that, okay, in that specific context, it's not necessarily about model performance, but maybe it's about calibration. So it's a different metric that we not necessarily thought of initially when working on this. And I think it's another dimension when we think about kind of generalizing this kind of way of thinking and applying survey methods and also assumptions coming from the survey field, that when it comes to model training, there's just a range of different kind of outcomes that you can look at. You have like a set of predictions, you can compute a bunch of different measures, and kind of being kind of clear and having a good idea of which measure exactly is affected by the thing that we vary at the beginning, sort of. I think that's another important component when it comes to doing this type of work for other tasks.
So these machine learning models, they have features. They have a number of, let's say, variables that you would use to predict, would it go even as far as that the importances of these features or the features themselves that go into these models change based on these tactics? Is it that influential? For example, would you include the features of the annotator as part of the prediction?
It's a super interesting question. I think actually we have not looked at this at this point, but it clearly makes sense. I mean, in the current setup, it's sort of only taking sort of features from the object we want to classify itself. But when it comes to weighting, it's almost like kind of similar to kind of as adding kind of a weighting factor, incorporating the composition or kind of the demographic features of the annotators, which is sort of what the weighting factor is summarizing in a sense. So it might be a similar or equivalent way of actually kind of doing this, but I think we haven't looked at this yet.
If true, it would even sort of point at certain kind of annotators being much more interesting than others because they have certain features that are relatively rare in your pool of annotators, let's say. So you wouldn't like to lose them because there's that would be a step further, I guess. You would treat them maybe even differently a little bit than the others. Okay, maybe let's zoom out just a little bit. Because you've done this study, let's say, based on in the moment, in a particular time frame, the labeling was done. I guess things like hate speech and offensive language are relatively stable in time, unfortunately. But do you think there is something like a drift in here as well? If you would have to do this in 2 years from now, you would have to sort of start over a little bit with retraining, even go as far as checking whether the features need to be reconsidered or...
I think those challenges I think are kind of, at least in the data science world, kind of sort of quite well known. So I mean that there's a lot of work on distribution shift or like concept shift and drift and all of those things. So I think actually there the survey world can learn from the data science world in how to kind of think about those things, because it's sort of eventually those things arise when you think about deploying something, right? I mean, this is not just when you do kind of your own kind of research and it's like a one-off piece, but when you really think about, okay, I'm building something and I'm actually deploying it over time, right? And then I need to think about, okay, what happens if the input changes, or what happens if actually, and that's also I think a very big topic, if the output of my models change its environment such that sort of once I'm collecting new training data, the training data is affected by the model. Sort of, so you have sort of a performativity loop in a sense, which is a big and I think very new and important research stream in machine learning. We think about, okay, actually now we have a bunch of models all kind of affecting decisions in the real world, and this also affects their own training data eventually. So it's I quite think emerging and interesting field of research.
The question, of course, is probably it's interesting to see whether there is any change in time, whether people become a bit more offensive. There's all kinds of political context nowadays where sometimes it can be more sort of, I guess, accepted to use this kind of language. So you like to detect that there's a change, but at the same time, the vocabulary may also change, of course. People might use different words. Does that mean that you would, for example, have to sort of relabel old tweets or something like? How could you sort of distinguish these kind of real changes from method changes?
Yeah, I think the one thing that comes to mind is to think about the mechanism that is at play there. I might even think about how can we connect this to like different missing data mechanisms where I think, okay, is this about that our kind of sort of outcome changes, or is it that the base rate sort of changes? Is it about kind of in the feature space we have shifts, or is it about the relationship between features and the outcome changes? So maybe that is even like an instructive first step to understand, okay, we have like different moving parts here, and what exactly is kind of affected by those changes. Do we need to just sort of adjust for a shift in the baseline, so to speak, which would kind of speak to kind of calibration would be affected, but maybe not necessarily model performance, but is it about that kind of relationships really change? And then I think you kind of, you need to detect this early on, and most likely you need to retrain, because that is something that you cannot kind of wait away by kind of doing some things post hoc.
There's some interesting issues here around the target population issue that that Christoph and I both mentioned briefly. So for example, as you mentioned, Barry, like language evolves and new terms arise. And to be concrete about it, in the United States, I'm not sure how many people in Europe are aware of this, but in the United States, recently the term "Let's go Brandon" became a slur. And so that's something that arose sort of very quickly among a very special population of Americans, probably mostly. Not everybody was aware of that. And so who are the right people to label tweets like that? You have to be maybe young and online to really know what that means and that it's a slur. So if you have a representative sample, like a representative sample of the US population labeling tweets, they may not see that as hateful on average because they're not the target audience for that slur. They're not part of the in-group that gets it, right? So that kind of becomes like, who are you trying to represent when you're labeling these kind of data, right? You have to make sure you get the right people labeling each tweet individually even. So those kind of questions can get really difficult. Another issue that Christoph mentioned is oftentimes you'd have 3 or 5 people label the same instance of data, right? And you might then take the modal response. It's of a binary label. Is this a picture of is there a dog in this photo? Yes, no. Well, 2 of the 3 people said there's a dog in there. So we're going to say the gold standard is that yes, there's a dog. When you do that, you're really throwing away quite a lot of information. Like, well, hey, 1/3 of the people don't see a dog in this photo. Maybe that means something, right? And sure, we can go to another odd number, like 29 labelers, right? And then take the modal there, but that gets expensive and you can't always afford to do too much there. And so it's particularly in the example of more subjective and hateful things, right? You might have 2 out of 3 people find a given tweet hateful, or maybe 2 out of 3, you might have 2 out of your 3 annotators find that a given tweet is not hateful, but that third person may be a homosexual who realizes that tweet is in fact very hateful and is the target of the hate in that tweet, and that's why they see it, right? Whereas the 2 from the majority population don't see it as hateful. And so therefore, it's just another situation in which taking the modal label really hides a lot of information and can get you into the wrong answer. So I think there's a lot of issues here around gold standards and target populations.
But what you're referring to is that what you're going to sort of label is not necessarily unidimensional. It's not even, if a cat or a dog in a photo, we can debate whether there is any overlap between cats and dogs, but it's relatively factual. There is a cat or a dog. But in the case of the hate speech, it's quite subjective. So maybe there might actually be multiple labels. One for people that don't feel attacked by it, and one for people that would feel attacked by it. Maybe just a little bit go back to the more statistical side of this. We talk a lot about the labels, and of course there's the machine learning. Machine learning there are so many options. There are so many techniques around. does that matter? You know, where you use a random forest, or I talked to Bolei and he said, well, it's a pretty straightforward machine learning model that we use. It was not, we didn't have to do a lot of tweaking. And for me, it's that it was, of course, I don't know. But would you say that the technique is robust to this, or is that also something that comes into play?
I think in the specific example of the paper that we're discussing with the labeling of hatefulness and offensive language of tweets, we did look at a couple, or let's say a few different model types. And I think for them, we've seen the same pattern, basically. So there, it was not a big factor, I would say. I could see maybe if you're kind of taking the extremes and you're looking at kind of very flexible methods versus maybe methods that are kind of more robust or like less flexible, maybe there's a difference. I could see that there maybe the less flexible ones might not pick up all of the nuances of the different conditions that we had. That could be, but I think for the most part, it shouldn't be. Well, it's a very broad statement, but I would say it shouldn't be a big issue. It shouldn't make a big difference there. Eventually, I mean, they're all taking the training data and trying to find kind of patterns there. They're all, for the most part, very flexible and good at finding patterns. And if there are systematic differences between groups of annotators or different conditions, they will kind of incorporate and find them. And so I think for most part, most model types would be affected.
Well, I guess in a way that's good news. If there's not too much influence on otherwise it could be just one data scientist doing it and another, and they would also come at different conclusions because they have different preferred methods maybe. But if it's relatively robust, so that would be, of course, a good thing. I'd like to look a little bit ahead. So was this a one-time only study, or are you going to, well, do follow-up studies based on this? What are your plans for the coming year or years?
So the next priority for me is to start looking more at this representation question. We've done some work already on the measurement error. There's more to do there, expanding to different tasks, but I really want to dig into the representation area. I want to find out if it matters who you have annotating. And well, I think it does, at least for some tests. And so to figure out in a larger sense, like for which test does it matter who your annotators are? I think the survey world is well equipped to answer those questions. We spent the last 10 years or so talking about the difference between probability and non-probability surveys, and when is a non-probability survey sufficient. So I think we can dig into this issue with the annotation tasks and help our machine learning colleagues understand when they should be paying for high quality representative annotators and when they don't need to. We've already done one study that Christoph mentioned briefly with some simulations where we showed if the population of possible annotators is sort of 50% people who are more likely to find things hateful and offensive and 50% less likely to find things hateful and offensive. Does it matter how well that split is represented in the annotators that you actually use? So the annotator population is 50-50, but then we created different simulated data sets where maybe it was 75-25 or 25-75. We looked at different mixes of the two types of annotators and showed that, again, you get different performance of the models based on how well the mix of annotators matches the hypothesized population or the simulated population. And then we looked at a really simple way of duplicating labels by the underrepresented annotators and showing that this simple approach of just duplicating does make the ultimate models that you train more like the simulated population and more accurate than doing no adjustments for the different mixes of annotators. So we just did a simulation study where we played around with the mix of annotators. We hypothesized that the population had two different types of annotators, those more likely to see hate speech and offensive language, and those less likely. And then we simulated different annotated data sets where we played around with the mix there. So sometimes we overrepresented the one type of annotators and underrepresented the other. And we showed that the different mixes of annotators will lead to different models. And in fact, models do better when the mix in the annotation data set matches the population. We also tested a really simple technique for adjusting the annotation data set to look more like the population and showed that that worked rather well. This is a really simplistic approach. And the next thing I want to do is look at more statistical approaches to address imbalance between the annotators who participate in a given task and the actual population. I think there are a lot of really interesting statistical approaches here that, again, survey researchers are well positioned to address because we have so many weighting and calibration approaches that we can bring to this research.
Yeah, and adding on this, I think representation also more broadly, I think it's a super important concept when it comes to work outside of the labeling world, but when it comes to models that are kind of, again, used for informing real world decisions. There's this really big research on responsible AI and kind of fairness in machine learning. And there clearly, you want to think about representation and kind of who's included in the training data, because obviously it's hard for models to learn the right kind of decisions when there are just some groups not represented in their data. So kind of really having a focus on understanding where the data comes from, how it's collected, and how it aligns with the population that might be affected by those models is another kind of, I think a big research stream where kind of survey methods should play a big role.
Now, I know that maybe the hardest, if you really like a challenge in surveys, you need to go to cross-country, cross-cultural surveys. I think that's the toughest area. Is that true as well? And you think there is something there for cross-country machine learning? Or is that a bridge too far?
In our research, we haven't gotten to that bridge yet. I agree with you that that's very challenging in survey research and also very challenging in the annotation world as well. As Christoph was just saying, a lot of the labeling or the annotation that's being done now, and that I think will be more common in the future, is this kind of annotation used for reinforcement learning about like which of these two responses to a given query are the most fair or the least harmful. And those kind of judgments, first of all, are probably very susceptible to the representativity of the annotators. Like when you're doing those kinds of questions, that's when you really do need to make sure you've got a wide representation of the population. And you're not just using sort of an opt-in non-probability group of crowd workers. But exactly, but those are also the kind of cases where I think there's cross-cultural differences between countries, between ethnicities about fairness and harm that are really, I don't know how we're going to train one model to meet multiple definitions. That's a difficult question and not one I'm working on at this time.
Yeah, maybe a last, really a bit wild idea, I guess. When the previous ESRA moving about survey quality predictor, SQP, they were working on machine learning AI that would actually do all of the coding. So it's quite burdensome, right? Coding all your questions in your questionnaire, then get some predictions. What is the quality of this? So could you even imagine that in the tool, in the annotation tool itself, the AI gets a role, right? It's sort of like a communication with a annotator. It's not just a very simple tool where you see something, then you write something, but it's more like an interactive way of communication.
Yeah, I mean, it's a very interesting and it's a wild idea. I agree. what I can see, or what I find interesting in those kind of interactive contexts, is settings where you kind of try to sort of challenge the kind of labeler, maybe in a sense, not just like provide them additional kind of context information, but also kind of be adaptive to their responsive and responses in a sense, and then kind of understand when they are kind of maybe kind of becoming less attentive, and kind of trying to kind of make them more involved again in the task. So in that space, I think I could see some interesting applications also, maybe from an adaptive design perspective, even like.
Okay, we'll see where it goes. It's definitely a very vivid and dynamic area, and I think you're working on the frontier of this. So I learned a lot. I also learned there's still quite a lot of things to research and to. So there should be at least 5 ESRAs from here, or Big Surf conferences where we should go to your presentations, I guess. So thanks a lot for expressing your views and ideas and results, and hope to see you at one of these conferences.
Thank you, Barry.
Yes, thank you for the chance to speak about this research.
So thanks for watching this short movie. We talked a lot about representation today. That will be one of the upcoming topics of the short movies, namely inclusivity in surveys, an important topic nowadays. Another short movie that's coming up is on UI UX, so user interface, user experience. And not to forget, on the ESRA 25 conference in Utrecht, I will be there interviewing participants on the conference. And you could be one of them, of course. So hope to see you. Bye.